Okay, so in your notes already, there's a couple things you learned. One, you learned parent function of a quadratic equation. So that, your vertex, first of all, the parent function is y equals x squared. Your vertex is at 0, 0. The next point we can plug in, when it's 1, it's 1, 1. When it's 2, 2 squared is 4. And then 3, it would be all the way up to 9 here for us. And then obviously from last lesson or last couple lessons, we know that we can also graph their corresponding points. Since this is 1 unit to the right and above the vertex, its corresponding point is going to be 1 to the left and above. And then same for here. This is 2 to the right, so this is going to be 2 to the left and 4 above. 3 to the left and 9 above. Okay, so we have our corresponding points, so I could draw my sketch of my parabola. And it's going to look something like that. Notice how it's a U, not a V, because the only V graphs are absolute value graphs. Okay, so that's the parent function of a quadratic equation. Now, vertex form is nice because it helps us easily imagine what type of, or what the graph is going to look like, because we can find the vertex, and we also, from the vertex, can kind of see how it's going to be translated. So, the vertex form, as we know, or as I just put in the notes, your vertex is HK. So H is what makes this value equal to 0. But, so really all that matters is in the parentheses there, what's going to make that equal 0? Well, that's going to be -1. Notice how it's minus H here. So H is actually equals -1, because in this problem it's a +1. So minus a negative creates that plus, so that's why H is -1. And then we have our K of -4. Now notice how that's not the opposite, because in the problem here it's plus K. So if I had a plus here, it would be a plus and a -4. So that's why it's -1, -4 is our vertex. Okay, so you get that, how it's translated. Now that also means every other point of our parent function was also translated 1 unit to the left and down 4. So we had this 1, 1. Well, if I translate this 1 unit to the left and down 4, I'd be here at -3. But you could also get that by putting in what x is, so 0, plugging in 0, and then solving for y. So 0 plus 1 is 1, 1 squared is 1, 1 times 2 is 2, 2 minus 4 is -2. So that should be, oh, sorry. Yes, so every point is not moved down to the left, or moved over left 1 and down 4, because of the 2 in front. I forgot that was there. So that's why that doesn't necessarily work here. That's why it's -2 instead of -3, because it's multiplied by a factor of 2, which is going to shrink it from our graph, as we learned with absolute value functions. So we can plug 1 in, and we would get 1 plus 1, which is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 4 is 4. So when it's 1, we have 4. And then I think I plugged 2 in as well. 2 plus 1 is 3. 3 squared is 9. 9 times 2 is 18. 18 minus 4 is 14. So I could plot 2, 14, which is going to be up here somewhere. And then like I said on the note, you can always plot their corresponding points as well to get what the graph is going to be. So we're going to have that point. This is 2 away, so we're going to go 2 away and up to 4 there. And then we also have this -4, 14 all the way up here. So now we can have our sketch of our graph. And notice how it is more narrow than our parent function. Now if this 2 wasn't here, or if there wasn't a coefficient here, you could have used my theory of left 1, down 4 for every single one of your points. But because of that 2, you can't necessarily use that theory here, because that changes the shape, or not the shape, but changes the stretch or shrink of the graph.